It can be thought of as an open source transportation concept. It consists of a pod going inside of a tube as efficiently and as safely as possible. Now, in order to elicit technology innovation in this regard, we sent out an application for proposals about a year ago, in January of 2016, for student teams from all over the globe to submit their designs for what they would deem to be the best pod to travel through this test track that you see behind me. And the response was overwhelming, and it was international. We had teams from high school to postgraduate work. We had teams from Japan, Netherlands, Germany, Australia, and Canada, as well as here locally in America. Now, these teams flew in as early as last Sunday to conduct all of the prerequisite testing that they would need to get to the 10th and final milestone that they intend to complete this weekend, which is entrance into the Hyperloop track that you see behind me, pump down to vacuum, and see how fast those things can go. So they've been conducting tests over the past week. Now, we are going to show you pre-recorded footage of some of those tests, as well as interview some of the live teams as they step into some of those prerequisite tests today, as well as hear speeches from the Los Angeles Mayor, Eric Garcetti, Elon Musk, the one who put forward the initial Hyperloop Alpha paper, and much, much more. So with an exciting agenda ahead of us, let's get started.
Hey everyone, I'm John Federspiel, a lead mechanical engineer here at SpaceX, and I'm right here inside our exhibition area where we have 31 teams here showing off their pods to the general public and the other teams around here for the Hyperloop competition. Now, a Hyperloop is a new type of transportation that Elon, we've said before, popularized in 2013 when he released his initial alpha paper to the public. This alpha paper he worked on with engineers from Tesla Motors as well as SpaceX, and in this, he proposed a fifth mode of transportation. The first four modes obviously being planes, ships, trains, and automobiles. This fifth mode of transportation really evolves on these other four modes to both be faster, better, cheaper, and more convenient for its occupants, and this is what the Hyperloop was supposed to be. A Hyperloop is essentially a really big tube that is evacuated from all of the atmosphere on the inside, or nearly all of the atmosphere on the inside. In fact, the Hyperloop proposed in the initial alpha paper calls for an atmosphere that has 1/1000th the pressure of Earth, or about 1/6 the pressure on the surface of Mars. Now, because you evacuated the actual air within the tube, you don't have wind resistance as you push your pod or capsule down the tube, carrying the people or cargo you may need to go, so the pods can get to speeds upwards of 750 miles an hour. Now, we're not going to maybe see that today. Our tube is only 1¼ kilometers long, but we do expect to see speeds upwards of 80 miles an hour, perhaps, depending on how things go with the teams in testing for today's competition. Our tube here today, it's about 6 feet in diameter, but to compare that to other tubes that was proposed, the passenger concept was 7 feet in diameter, and the cargo version was about 10 feet in diameter. So while this tube is smaller, a little bit of a subscale, it's not too far off of being representative of the eventual vision of Hyperloop. This is, in fact, the very first Hyperloop track ever built. It's arguably the third largest vacuum chamber in the world, certainly the largest vacuum chamber by surface area alone. Inside of this tube, there are, every 100 feet, there's optical strips, and using those optical strips, our teams will navigate along. You'll also see on the screen, we have lights placed every 25 feet. We'll go into more details exactly how this tube is laid out and how the teams are using it and how it differs from the initial alpha paper proposal. But for now, let's talk a little bit more and consider what the teams are coming up to. Now, the teams and their pods and what they have, there's a variety of different designs that they have used to implement. They have air-bearing skis, potentially wheels, or magnetic levitation. The initial alpha paper proposed air-bearing skis, but we wanted these teams to have as much chance to innovate and propose different ideas and give them as much flexibility as possible. So we basically provided them a tube with a few constructs and limitations, let them try it and adapt. And in fact, the first competing team this morning was Massachusetts Institute of Technology with MIT Hyperloop. And Brian was there earlier this morning to check in with them and see how their testing run went.
I'm here live, and MIT's pod is inside the Hyperloop test track here in Hawthorne, California, and they're about to be the first team ever to send their pod through for a money run as fast as they can. You can hear the crowd cheering behind me. Remember, we depressurized the chamber over the past few minutes. MIT has passed all of the necessary prerequisites that they needed to ensure that their pod is as safe and as high performance as possible. Now it's about to kick off. Remember, the SpaceX pusher will bring it up to speed, then it will detach and let Hyperloop MIT do its thing. Now we have cameras inside of the test track itself. There are 8 of them that you will see on your webcast screen. There's a slight optical illusion that the track looks a little bit curvy. It's because it's a very, very long track and we have cameras placed at different angles. Some of them are pointing towards the pod, some of them are pointing away from the pod. So in certain frames of these, you'll see it ascending towards you. In other frames, you'll see it leaving. It will be departing from you. But we're very excited. Again, this is the first money run of MIT through the Hyperloop test track. Let's do it. Hi, I'm here with Charlie, another representative from MIT. Now, you guys just completed your first run through the test track, and you were the first student team to do so. Having flown all the way out here, designed your pod over the past year or so, describe what it feels like for that accomplishment.
Yeah, it's been just a wild journey for us. I mean, a year ago we were at Design Weekend in Texas. That went all really well, and then we've had just a crazy time over the last year, putting the pod together, getting everything tested, working out. And today, we had a great time to show it off. Got up to about 80 kilometers an hour down the tube. I think that's what all the vehicles are going to be doing today.
Okay.
But yeah, from the screens, looks like it was a really smooth run. And we'll check it out when it's done. But yeah, we're really pumped. So
awesome. So 80 kilometers per hour. That is a fantastic speed, and you guys have set the bar for the remainder of the teams that have made it to the final competition stage. Having won the design competition a year ago, tell me what about today surprised you? Was there anything that met your expectations, surpassed them, didn't meet them?
Yeah, I mean, for us, it was just awesome seeing so many teams here with hardware. I mean, a year ago there were 30 teams that made it through. I think around 30 teams that made it to today's competition, and almost that many actually have like a full working pod at competition, which has just blown everyone away. There's such a variety of designs, variety of awesome approaches to solving this problem. I think we're just impressed with what everyone's done. So,
as is everybody else, you guys have been one of the leading teams this entire competition. Now that the excitement of your initial run has passed, what was one thing that you were most certain was going to work perfectly, and what was one thing that you were a little bit worried might not be up to snuff in your pod?
Well, because of the design of our pod, we can't actually push it at speed when we're not in the tube at SpaceX. So this was actually the first time we've run at high speed. So that was a little bit of a nervous moment for us the first time we shoved off, but looks like it all went well. Other than that, we were just pretty confident in the design overall. We did lots of testing, and it looks like it worked out. So
that's the right answer. So having been through the track, what's next for MIT? This is competition weekend number 1. Competition weekend number 2 is this upcoming summer. Are you guys going to go back to the drawing board and tweak a few things? Do you think it's sufficient as is? Where does MIT Hyperloop technology go from here?
Yeah, so we're not really sure yet what's going to be happening. We'll probably be working with SpaceX to make a decision on that. We're pretty confident in the pod we have. So the speeds today, again, we're about 80 kilometers an hour, but we're designed to go up to about 250 miles an hour, which is about 400 kilometers an hour.
Sure.
So about 5 times as fast. So we think the pod can do it, and if they let us run the pod in the future, then that would be awesome. So.
Last question before we let you go.
Sure.
If you could build a Hyperloop from your university at MIT to any other city so that you could take advantage of this technology that you guys are help enabling, where would you build it to?
Well, I'm a Colorado native, and I miss the outdoors, so that's just got to be my answer. So
Sure. Well, it's been a pleasure having you, Charlie. Appreciate it. Best of luck to you and the MIT team.
Hey, thank you so much.
And so that was our first run of the day with the Massachusetts Institute of Technology, MIT Hyperloop. We're expecting 2 more runs in the chamber at the full vacuum level from War Hyperloop of Technical University of Munich and Delft University, our Delft Hyperloop from Delft University of Technology. So both of those 2 teams will be coming up. In about another hour or 2, we'll see the first one, probably about an hour for War Hyperloop. In about another 15 minutes, we're going to hear from Mayor Garcetti and Elon Musk. But first, let's learn a little bit more about Hyperloop, some Hyperloop 101 with 2 of our engineers at SpaceX, Flo Lee and Steve Davis. They were the people instrumental in leading the development of this Hyperloop competition to tell us a little bit more about that student experience and also what this competition is all about.
Hi, I'm Steve Davis. I'm the Director of Advanced Projects at SpaceX. Hyperloop is a point-to-point transportation system over ground that's meant to allow people to travel at extremely high speeds, up to 700 miles an hour. The idea originated from Elon back in 2013 when he noticed that the increase in speeds over ground hadn't really increased by any significant amount in very, very long time. He also noticed that he himself was sitting in traffic a lot, and there has to be a solution. So he created the concept of a Hyperloop in order to give the world kind of a solution that could solve these 2 problems. And so we thought a great way for kind of the world to innovate would be to throw a student competition where we built a test track, a Hyperloop test track, and then invited student teams from around the world to build the best possible pod to go in that test track. And we left the competition very, very broad, so you could come with any really design that we can, as long as it was safe, you could do it. And so we conceived of that idea, and then in 2015, we launched the competition. We really didn't know what kind of reception we were going to get, but within a week we had 1,700 entries, which was astonishing. From there, we gave a few assignments, and eventually we narrowed it down to 120 universities. They all came to Texas A&M for Design Weekend in January 2016, where we had a great design competition. This week we have 27 teams representing 6 different countries. There's also a high school team here. And so the amazing response, not only from America, but from the entire world, is astonishing. We have had teams fly out from Japan, from Australia, from Germany, from the Netherlands, all for this competition, which we really appreciate.
Hi, I'm Flo Lee. I'm the senior engineer at SpaceX. So I've been working on the competition for over the last year, and specifically I've been working on the tube construction, and also been advising a lot of the teams. So this is actually the first functioning Hyperloop track. So it's really exciting. We think it's probably around a half scale for what you would use commercially. This is a 6-foot outer diameter. The tube is 4,150 feet long. We started with all the concrete foundation, and then once all the cradles were in place, we brought all the pipe in. The pipe came in 50-foot sections, and we welded it all together, and that happened in a span of over 2 weeks. And then we started working on the interior of the track, laying concrete, and then the interior aluminum subtrack after that.
So one of the main purposes of this competition was not to kind of constrain the students. The whole point was to innovate. So if you gave somebody at this point in society a train track and said build a train, most of the trains are probably going to look the same. So what we did is we created a Hyperloop test track that could accommodate almost any type of levitation. And so the 3 ones that kind of came out of that were air, meaning like an air bearing, like an air hockey table. That's what Elon originally proposed back in 2013. So this track allows for that. It also has a certain type of sub-track, we call it, which allows for magnetic levitation. So the majority of the teams actually have pursued magnetic levitation. And finally, there's a concrete outer side, which allows for wheeled teams. If you want to build essentially an electric car in a vacuum, you have the option to do that. You can make a great argument for any of the 3 being the best. And so it's really each team can put their own idea. And so when you look at the pods, none of them look even close to alike, which is fantastic. The team from Japan's pod, you can literally fit in your hands. I'm sure it probably weighs 30 or 40 pounds. The team from Lehigh has a pod that I believe weighs over 3,000 pounds. So, the range is enormous. I believe the Japanese pod is maybe a foot long, and the Lehigh pod is 21 feet long.
So because this is such a large chamber and it takes a lot of power and a lot of resources for us to pump it down, we want to make sure before we put the pods in here that nothing is going to happen to them under a vacuum. So we have a smaller vacuum chamber. It's basically a 25-foot section of this tube where we pump the pod down to vacuum, and they have to do full functional checks and verify that everything is operating properly under vacuum. And if they pass that gate, then that's one of the things that they have to pass to get into the main tube. The other gate they have to pass is called the external subtrack, and that is basically an outdoor version of the track that's inside the tube. And on that track, they need to prove to us that they can, one, fit, so they have to align with the rail and fit on the track. They also have to show that they can brake, so they need to prove low-speed braking to us. Braking is very important. They also can show us general navigation, or they can also kind of prove out some of their levitation at low speed. We actually have a pusher at low speed to get them up to speed there, because some teams need to be at, say, maybe 15 miles an hour to actually levitate. So we've been able to show that on the subtrack first before getting them in here. If a team passes all of the gates to get in the actual tube, we're going to bring them out here on the loading dock. They're going to have to mate inside the tube, so basically we'll roll them inside the tube. After that, our pusher comes in behind. They need to verify that they have proper communication. Once all that is completed, we will close the door, and then we pump down the tube. Different teams want to go to different pressure levels, but if we go down to like a fairly low level, it'll probably take about 30 minutes. At that point, we will accelerate them with our pusher, and then they will be in the acceleration phase. After our pusher stops, they're in a coast phase, and ideally they'd coast all the way down, and then they'd hit a certain level where they hit their brakes and ride right up until the end. And if they can do that at the fastest speed, then they win.
The fastest team wins. So as long as everything is safe, which we ensure, whoever gets through that tube the fastest is going to be declared the winner. Just seeing the different designs has been amazing. If you walk around, it's 27 completely different designs, which is amazing. I'm super excited to see the first team get through this, because this is very non-trivial for the student teams. I mean, the tube behind you is a static tube; it doesn't really move. There's some thermal expansion, but it's not actively moving. These pods have a lot to do. They have to levitate, they have to have lateral control, they have to brake, they have to navigate. There's a lot of action, and they haven't had much time to build it. So if a school is successfully able to get through this final, I call it Test 102, which is the Hyperloop launch, that would be spectacular.
The teams are extremely excited about Hyperloop. The ideas that they've come up with, all the things that they want to try out for technology have been really impressive to me. Like, there's many teams that aren't necessarily just optimizing to win. They're here to try out new technology and things that they think will actually make this become a reality. And I think that's been really, really cool to see.
So needless to say, Hyperloop is going to be a very challenging competition. You can just see by the complexity of all these pods, the number of innovations they had to do just to get to this point. And just from the judging from the first test run to the two more we have, it should be a very exciting day today to see which team pulls out with that top speed score that we're looking for. Coming up right now, though, we do have a welcoming ceremony. We have Los Angeles Mayor Eric Garcetti here. He's going to be kicking off the whole celebration here, as we then introduce Elon Musk, who will be talking a little bit more about the Hyperloop concept and today's competition and where he sees transportation and the future of it all heading. So let's just sit back here and give it a few moments here as we wait and tune in and listen in for Mayor Garcetti and Elon's remarks.